So ratio units, what are they? What are they all about? Well, ratio units is not a term that you will find in your book, okay? But I think it's something that you should be familiar with. And basically, a ratio unit is a unit that is in a fraction form. And when I mean fraction form, typically you're going to have a value on the top of the fraction and then typically a value on the bottom of the fraction. And the value on the bottom of the fraction usually is 1. Okay, so it's a ratio of something. And some examples in physics of common ratios would be velocity. Okay, so I'm going to talk a little bit about velocity here. Does anyone know what the units are for velocity in physics? Meters per second. Very good. Okay. So when you say something has a velocity, typically you're measuring it in meters per second. And a ratio unit would be like if I say a toy car has a velocity of 3 meters per second, how I'd write that as a ratio unit is I'd write 3m over 1s. Okay, this is a ratio unit here. Basically what this is saying is that for every second that passes by, this object is going to move 3 meters, or 3 of those wood sticks that you guys were using yesterday to measure things. Okay, so what's kind of cool about that is I can now ask you, well, like in 5 seconds, how far will this car or toy car have traveled? 15 meters. Basically, you're going to multiply the bottom by 5, so that would be 5 seconds, and you multiply the top by 5, and you'd be left with 15 meters. Okay, in 5 seconds, this thing would have traveled 15 meters. And you again could simplify it and see that it has a velocity of 3 meters per second. A lot of times students will go through a whole year of physics and they never will have an understanding of what velocity is actually telling them. And that's why I think ratio units are so powerful. If you can get an idea, your mind wrapped around this idea of that velocity is how many meters I'm traveling for every second, it kind of helps you understand what the numbers are saying and what the units are saying. Another good example of a ratio unit is power. Does anyone know the unit of power? Watt is the unit of power. Not a good enough hint? Okay. The watt is the unit of power. Okay. So a watt, where do you see this? Well, check out your light bulbs, and on the top of a light bulb, typically they have how many watts the light bulb is. So a watt is actually a measure of joules per second. That's what a watt actually is. And a joule is a measure of energy, and a second is a measure of time. And so when I write, like, I have a light bulb with a power rating of 40 watts, what is that actually saying? Well, that's actually saying that that light bulb uses 40 joules for every 1 second. Okay? And once again, students will go through a whole year of physics and we'll talk about power in a variety of forms. In electricity, we'll talk about power that you might generate from your body. And they never will get this idea that a watt is actually an amount of energy used over a period of time. So I could ask you, like, in 5 seconds, how many joules does this light bulb use? That's in 1 second, it uses 40 joules. What about in 5 seconds? 200, okay? And again, if you can kind of wrap your mind around this idea that what is a watt, what is velocity, and we didn't talk about volts or accelerations or anything like that yet, but what is a volt, it kind of really helps you, at least I think anyway, get a stronger understanding for what those units mean. The units are there to help you, at least I feel anyway. Things that are not a ratio unit would be something like, for instance, time. If I say something ran for 5 seconds, that's not a ratio unit. Okay, it's just 5 seconds. Okay, 5 seconds went by. Or distance is not a ratio unit. If I were to say, like, the nurse's office is 10 meters away, 10 meters is not a ratio unit. Okay, so those are examples of not ratio units. Hopefully it's okay, but I'm going to delete this. All right, moving on down. Now we're kind of switching gears, talking about dimensional analysis. Dimensional analysis is a way to convert one type of unit to another. And the key to being successful at dimensional analysis is to focus on the units. Okay, that is a key component, is focusing on the units. You basically want to make them cancel each other out, and when you are done, you should be left with the unit that you are going for. Okay, so here's some example problems of dimensional analysis. I ask you to convert 20 inches to centimeters. Okay, so I want to go 20 inches to centimeters, and I tell you what the conversion ratio is. 1 inch is 2.54 centimeters. So I would write 20 inches right here, and you can put this over 1 if you'd like, just to kind of help you see things. And then I'm going to multiply this by some ratio, okay? If I want inches to cancel, would I put inches on the bottom or the top?
Bottom.
Very good. Put inches on the bottom. Okay. Now I look at my ratio here, and it says 1 inch, so I'm going to write 1 inch. 1 inch equals how many centimeters? 2.54, and I'm going to write that up here. Notice the top number is what I want it to be in. I want it to be in centimeters. So inches will cancel, and I want it to be in centimeters. So if you take 20 times 2.54, I believe you get 50.8 centimeters. And that would be my answer. All right. Let's try another one. It says convert 40 pounds to grams, to the gram. So I have 40 pounds, and if you want to put it over 1, you certainly can if that helps you see things. Now, I want to get rid of pounds, so would I put it on the top or the bottom of this fraction? The bottom, right? And now I just look at my conversion factor here. 1 kilogram equals, I'm sorry, I lied. 1 kilogram equals 2.2 pounds. Okay, so I'm going to write 2.2 down here, because I have to make it match with the unit. 2.2 pounds is the equivalent of 1 kilogram. All right. Now I'm going to multiply what? How do I get rid of kilograms? Bottom or top? Bottom. Okay, good. And I look at my conversion factor here. 1 kilogram is equal to 1,000 grams. And so if you were to throw this in your calculator, you would take 40 divided by 2.2 times 1,000. And if you do that math problem, you should get something along the lines of 18,181.8 grams. Hopefully. Okay. Now, you know, if you can do this without like writing this all out, that's perfectly fine. But I'm just kind of showing you like the step by step method on how you would do this. Okay. Let's do one more problem. I hope it's okay. I'm going to erase this. I don't know how I can just move down without doing that. So I don't know about you, but when I turned 21, the first thing I thought was, how many minutes had I been alive on Earth? So we're going to find out the answer to that question. If you're 21 years old, how many minutes have you been alive on Earth? Okay. So I'm going to start with writing 21 years, and if you want to put this over 1, be my guest. Now I want to get rid of years, so I'm going to put that on the bottom of the fraction, right? Years. Now what is the conversion of years to days? Well, it's right here. 1 year is equal to 365 days. We're assuming no leap years, that like they don't exist. Okay. Now, I don't want to know how many days I've been alive. I want to know how many minutes I've been alive. So in one day, there are 24 hours. So I want to cancel out days. So I'm going to put days on the bottom. And in one day, there are 24 hours. Okay. Now, I don't want to know how many hours I've been alive. I want to know how many minutes I've been alive. So I want to cancel out hours. I'm going to put that on the bottom. In 1 hour, last time I checked, there were 60 minutes. I just feel like changing colors because it sounds exciting. So if we go through and see if our units cancel, the years cancel, the days cancel, the hours cancel, and you're left with minutes, which is what you were looking for in the first place. And basically, if you throw that in your calculator, 21 times 365 times 24 times 60, you get a grand total of 11,037,600 minutes. Okay. So that's how long you have to wait until you turn 21. That many minutes.